Hello and welcome. Today we're going to be looking at linear and quadratic systems as part of the Passport to Advanced Mathematics. As always, we're going to be looking at 5 questions and explaining them to find the intricacies of this topic so that you can ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get into our first question. Here it is. Negative 7x squared equals y plus 5 times y minus 5, and 5y equals 15x. Well, let's see how we're going to approach this question. We take the second equation, and we have 5y equals 15x. And let's divide by 5 on both sides to get that y equals 3x. All right, now what are we going to do? Let's take this equation and expand it out to get negative 7x squared equals y squared minus 25. Right, y squared minus 25. And now we have that y equals 3x, so we can substitute this into here, right? Now, we'll substitute that in there, and we get that negative 7x squared equals 9x squared minus 25. So we might like terms and get 16x squared equals 25, which means that x squared equals 25 over 16. And then x is going to be either 5 fourths or negative 5 fourths, but they are telling us that a is going to be greater than 0, so we're going to go with the 5 fourths option. All right, that is our answer. Let's continue. All right, question number 2, and it is y equals 2 minus 3x and y equals 5 squared. Well, since y equals y, obviously we can set these two equal to each other and say that 2 minus 3x equals 5x squared. We can combine the like terms to get everything on one side, and we have 5x squared plus 3x minus 2 equals 0, right? We can either factor this, or we can try the quadratic formula. Let's at least first try factoring. Have 5x here, x here, and let's see, we can try 2 here, 1 here, plus here, negative there. And that gives us 5x squared, and then the minus 2x and the plus 5x make plus 3x, and then we have a negative 2. So that works out. That's our factors, which means that our roots here are going to be 2 fifths and negative 1, but x has to be x is greater than 0, as they told us. So our answer is going to be 2 fifths. And let's move on. All right, question number 3. Here we are, 2x plus 3y equals negative 8, and 3y squared minus 8y equals 2x plus 10. And x1, y1, and x2, y2 are distinct solutions to the systems of equations shown above, and we're asked for the product of x1 and x2. All right, let's see how we can go about doing this problem. Well, what can we do? So we can subtract out the 3y from the first equation, and we get 2x equals negative 8 minus 3y. And then we can take that 2x and substitute it in there, right? And that would give us 3y squared minus 8y equals negative 3y, and then minus 8 plus 10, so it's going to be plus 2. All right, let's get rid of this, the bottom. And now we can take these terms and combine them. We get 3y squared, and then minus 5y minus 2 equals 0. Let's try our hand at factoring this. All right, so 3y here, that, let's try the negative 2 here, the positive 1 here. That gives us 3y squared plus y minus 6y. That gives us the negative 5y. And then we have negative 2, so that's our correct factor. So then the y is going to be negative 1/3 here, and 2 are our y values. So we want our x values. back into the equation. This looks like the easiest one to do. So we plug in those there and we get, for the first one, we have 2x minus 1 equals negative 8. So 2x equals negative 7 and x is negative 7 halves. The second one, 2x plus 6 equals negative 8. So we subtract the 6 off, we get 2x is negative 14 and x is negative 7. So x is negative 7. So x is negative 7 and x is negative 7 halves. The product of those is going to be 49 over 2. And that's our answer, 49 over 2. Now this does seem to be a kind of odd answer since it's a fraction and it's like, it has nothing specific, but let's see, let's just make sure that this actually works, right? So our first one was negative 7, and that went with 2, and the second one was negative 7 halves, which went with negative 1/3. So we already checked those in the first equation. Now we're going to check them for the second equation. All right. So we can plug in the y in the for negative 7, 2, and we get 12 minus 16 is negative 4, which equals the negative 14 plus 10, which is negative 4. So that works. And then the other one is going to be, you plug in the negative 1/3, and you get 1/9 times 3, which is going to be 1/3, and then plus the 8/3, which is going to be the, so 1/3 plus the 8/3 is going to be 3. And then you have the negative 7 halves, which is negative 7 plus 10, also 3. So these two are the correct solutions. Our product is 49 over 2. And so that is our answer. And let's move on. All right, question 4. And we're given that 4y squared plus 9 equals 6x plus 3, and 4y equals 2x plus 1. Well, the first thing I see is that if I multiply the second equation by 3, then I get this. The right-hand side is going to equal. So if I can multiply that by 3 and get 4y squared plus 9 equals 12y, which means that I can also write this as, oops, I can write that 4y squared minus 12y plus 9 equals 0. And if you've seen this form, you'll know how to factor it. If you haven't, it is a square, perfect square. And so this is 2y minus 3 squared, which means that the y that makes this a 0 is just going to be 3 halves equals y. And since 4y equals 2x plus 1, as we see in the second equation, then we realize that you can see that, wait, is that what we had for, we had 3 halves. I don't know where I got the 1/3 from. It did seem to be a bit off, but so y is 3 halves, not 1/3. Sorry about that. And then the, so don't erase your work on the SAT. Like, please don't. I just don't have enough space. But you will have enough space for on the scratch paper. So this is going to be 4 times 3 halves, which is 6, equals the 2x plus 1, which means that x is going to be 5 over 2. And we did all that, and then I just, you didn't have to do that because they asked for the value of y. This is why you read the question, right? At least like if you're gonna do like this, like I did, and find x, like at least read the question before you put your answer, right? At least do that. But yeah, so we have 3 halves as our y value. If we want to check it, we can. We can just plug it in right now, and we see that. Let's see, does it work? 3 halves, 9, and that does seem to work. So let's go on to question number 5, and here we are. 2x minus 6y equals 9. 7 minus 2y equals 15x minus x squared. All right, let's see what we can do right here. All right, I'm going to take the second equation and multiply it by negative 3. And we're going to get 2x minus 6y equals 9. And 21, well, or negative 21 plus 6y equals 45x minus 3x squared, or negative 45x plus 3x squared. Remember to multiply by the negative. And then these two are going to cancel out, and we're left with just 2x minus 21 equals 3x squared minus 45x plus 9. And let's see what we can do. So we add the 29 to both sides, we subtract the 2x from both sides, and we're left with 3x squared minus 47x plus 30. Let's try to factor this. Let's see. Or before we factor it, let's try something else. This is why you read the question, as we said before. They're asking for us for the product. So let me clear this and then rewrite the equation. So they're asking us for the product. They're asking us for the product of x1 and x2. They're asking us for the product of the roots. And to find the product of the roots, you do not necessarily have to find the actual roots themselves. All right, you don't have to find the actual roots themselves. You just have to find their product. And if you, I don't know if you know this thing called Vieta's formulas, but they're extremely useful. And they essentially say that if you have ax squared plus bx plus c, the sum of the roots is negative b over a, and the product of the roots is c over a. Now, c over a right now is just 30 over 3, which is 10. So this suggests that it should be 10. Now, of course, let's make sure that it is. We're not going to actually go through and find it itself because that would be much too tedious. I just remember you have the Vieta's formulas handy in case you need them, but we are going to make sure that we got the right quadratic because that is where we got this Vieta's formulas from, and we really need to make sure that our quadratic is correct. So 2x minus 6y equals 9, and then we multiply. Let's multiply by 3 this time so we don't have any negatives. 21 minus 6y equals 45x minus 3x squared. Then we have to subtract one from the other. And then we get 2x minus 21 equals 9 minus 45x plus the 3x squared, which means that when we get this all done, we're going to have 30 as c. We're going to have 3 as a, and our product is going to be 10. So that's correct. And we can, that is our product of the roots. We didn't have to do any of the actual finding the roots, so we used Vieta's formulas. Incredibly useful. Remember those. Remember how to manipulate the equations algebraically, and just do what the question asks you to. It's not very difficult in these questions, and I'll see you next time.